I'm Jen Haas, and I'm the Vice President of Marketing at Aventura, and I'd like to welcome everyone to today's event. The topic of today's webinar stems from recent conversations that our team has had with healthcare provider organizations around workflow, the need for interoperability, and how the emerging standards such as FHIR and SMART will improve the care delivery process. The goal of today's webinar is to address some of the key questions that we've been hearing, such as what lies ahead as FHIR and SMART become mainstream, what are the key benefits of adopting FHIR and SMART, and what should organizations be doing to prepare for the future? Moderating today's session is Dr. John Glasser. John is the Senior Vice President at Cerner, and prior to joining Cerner, John was the CEO of the Health Services Business Unit of Siemens Healthcare. He's previously served as Vice President and CIO at Partners Healthcare, and with that, I'd like to turn it over to John to moderate today's session.
Thanks, Jen. My name is John Glasser, and it's a very pleasure to have all of you here. I am joined today by two colleagues who are quite well known and have done remarkable work. The first is Ken Mandel, who is Director of the Boston Children's Hospital Computational Health Informatics Program. He's also a Professor of Biomedical Informatics at the Harvard Medical School and is the lead and chair of the SMART Advisory Committee. We're also joined by John Hotchkiss. He is the founder and Chief Technology Officer of Context Informatics. So I'm going to give a couple of comments just about interoperability writ large, and then turn it over to my two colleagues who will go into more detail on both SMART and FHIR. Now, the main point I have in the next couple of slides is above and beyond this opening definition of interoperability, and there are lots of definitions of interoperability that are out there. I want to sort of highlight the fact that there is a very significant national emphasis and presence and effort to spur the advancement of interoperability, which is what you all know, and one of the reasons that you all are on this particular presentation. So one of the things that we see in addition to this definition, which you have in front of you, is we see a lot of action in Congress. And so I'm not going to go through the specifics of this slide here, but legislation was passed by the House back in July dealing with interoperability as part of a broader set of legislation to advance scientific discovery and the movement of invention from the bench to the bedside. Again, here's a particular piece that looks at defining interoperability, setting national goals for interoperability, addressing the standards process, dealing with the topic of information blocking. The Senate version is being worked on now. We expect that the result will be legislation passed sometime this winter. So interoperability has drawn the attention of Congress, and we will expect to see in the next couple of months legislation reflecting Congress's effort to improve or advance interoperability. And it's not just Congress. Meaningful use is, the program is winding down. Stage 3 is the last stage. The ink is still not dry on that. There may be further revision. But even when it disappears, we will see interoperability and other CMS regulations. So examples are here. The first one, the physician SGR fix, where we fix physician payments. In addition to correcting payment issues for the doctors, also introduce topics of interoperability, essentially saying that there's going to be, it must be achieved by the end of 2018. The HHS has developed measures for this, et cetera, and to deal with issues of information blocking. So the point being, in addition to Congress, CMS will continue to issue regulations as part of its normal regulatory process that reflect and drive interoperability. This is coupled with, as you probably know, the ONC plan for interoperability, which was debuted a couple of months ago, and so we'll continue to see their efforts. And finally, coupled by, it's not just government is pushing hard on this, but perhaps because of government pressure, but a wide variety of reasons, the industry is stepping up in lots of different forms, whether it's Commonwealth, or the Sequoia Project, or the Center for Medical Interoperability out of San Diego, or the AHA and the AMA and other activities, all centered on bringing together providers, health plans, public health, and the vendor community to advance interoperability. So a lot of emphasis, a lot of interest on this particular topic, I suspect you all will know. Now within that and all the different pieces that have to come together for interoperability to be truly advanced, two of the more significant aspects of the future, which I think will enable us to catapult or make material advances in our ability to connect systems to systems and systems to devices, will be the emerging development of standards and technology to support that standard, both SMART and FHIR. So the first speaker we have, and I'll turn it over to him in 1 second, is John Hotchkiss, who will now give you an overview of the FHIR standard. And again, I'd like you to make sure you keep your questions coming. I see a couple already, and I look forward to addressing those when John and Ken are done. So John, it's all yours.
Thank you, John. Appreciate it. I'm very excited to be able to talk to you all about the FHIR standard today. I'm excited for a couple of reasons. One, I've spent, like many people on the call, I'm sure, a couple of decades working on applications and platforms to create interoperability between medical applications. In my case, it's been working on systems for patient safety, situational awareness, for clinical quality reporting and monitoring, and more recently working with Aventura on their platform and interoperability support in that platform. Today, what I'd like to talk about in this brief introduction, because FHIR's a significant standard covering a lot of ground, I want to give you a sense of the motivation behind the standard, what they're designing for, a taste of how it works and what it is, so you get an idea of what's causing the excitement behind this standard, some sense of its direction, where it is in its timeline, and some advice on what I think we should be doing in our institutions to adopt and to take advantage of what's going on in the FHIR standard. First, the motivations. This can really be captured, I think, in a nutshell, which is to bring interoperability programming into the 21st century. For all of us that have worked with previous protocols for interoperability in healthcare, the appearance of web-like interfaces that are familiar to modern programmers, support for scalable architectures like RESTful interfaces, document exchange, messaging, and service-oriented architectures, and the ability to take advantage of modern protocols for deployment and security, makes a huge difference. It really allows us to build into the modern programming and application development infrastructure. And that, I think, is what's really motivating a lot of the excitement around the FHIR standard. There's other things as well, for instance, the fact that this is a freely licensed standard. There are no restrictions on its use other than protecting the trademark of it. So they've really done a nice job of trying to create a standard that can be picked up and used by modern programmers in commercial and public environments. The name of the standard, of course, is FAST Healthcare Interoperability Resources. So resources are the key element here. And all exchangeable data is represented in resources. And a resource is really something, it's really nothing more in some sense than a chunk of data stored in a location that is clearly identified and accessible. So, for example, it's like a web page. FHIR resources have three main components. They have data that's usually represented as JSON or XML, and I'll talk about JSON in a minute. It has a narrative, though it's not required that every resource have one. It's strongly recommended. And the narrative is a human-readable part of the resource, and that's there to help assure quality and correctness in the use of the standard. And lastly, it has an extension component, because one of the nice things about the standards effort is that rather than trying to capture every possible permutation or data element in a resource, they've created a common way to develop and support extensions for each resource. So they can build the standard on an 80-20 rule and make sure that they're covering what most people need, and yet still allowing local and even national extensions to these resources to supply deeper data connection if needed. So what are these resources? Well, in defining the resources, of course, they have a Goldilocks problem. They want to make sure that they're getting components that are general enough to capture more than a number of possible representations, but not so so general that they're big and they only end up with 5 of them that have to capture all data elements. So right now they're at about 100 resource types in the FHIR standard. And they break down into these resource categories: clinical resources, identification like patient and location, workflow like encounters, infrastructure, conformance, and financial. I've put just a few examples on this slide. There's a full list at the FHIR website, which I'll give you the URL for at the end of this presentation. And it's worth taking a look at because I think it really gives you some idea of how they're thinking about segmenting the space and the information that needs to be interchanged by an interoperability standard. The other modernization, if you will, that FHIR presents is supporting more modern architectural paradigms. I'm going to talk more about the RESTful paradigm in a minute, but I do want to make sure that I've made it clear that FHIR not only supports a simple web-like interface, which is, I think, what's generated a lot of excitement, but it also can exchange documents and messages and support more sophisticated service-oriented architectures for applications that really need that kind of interaction and state maintenance. In the RESTful paradigm, the FHIR interactions map really nicely to the HTTP methods, and that's the implementation strategy that the FHIR servers are now taking, and that make it so easy to build applications on top of this FHIR architecture. REST, for those that don't know it, stands for Representational State Transfer, which it never seems to help me explain it very much, but really it's asking a web server, an HTTP server, to give you a chunk of XML or a chunk of JSON that represents that resource. So it's really an ask and you shall receive sort of paradigm. Very simple. Because we're also used to using HTTP for building applications, it's very comfortable for modern programmers. And here's an example of what that looks like. Here we're connecting using an HTTP call, and you can type this into your browser to connect to Graham Greaves' reference implementation. You'll hear me use his name. Graham Greaves is often credited as the architect of FHIR. So this connects to his reference implementation. And the first part of the URL is the location of the FHIR server. And then you have the name of the resource, patient, name of the resource type rather, patient. And then this is a search query in FHIR. So the question mark indicates that I want to search on the name component of that resource and find John Doe. And one last thing, I'm interested in having it return the XML. So I tell it that I'm interested in the XML format of the resource. And submitting that to a FHIR server gets you back this chunk of XML, which you can see is the patient resource with the names, birth date, gender, etc. Here's the same example done in JSON, which is an alternative representation also supported by the FHIR standard. So FHIR servers can choose to support one or the other or both of these representations. In this case, you'll notice JSON, just for those who aren't familiar with it, is JavaScript object notation. Ironically, given its name, it's actually a language-independent data representation that most modern languages and tool sets work with very well now. So the JSON representation, I think, is very interesting, and we're seeing native support for JSON in common, even relational databases coming into play now as well. One other point from this example, if you look in the middle at the HTTP full URL, you'll see that's the address, that's the identity for that patient, right? And so that's the standard way of addressing a resource in FHIR. You have the path name to the server, followed by the resource type, followed by the ID of the resource. And that always takes you directly to this record. So that gives you a taste or a flavor of how the resources are used, how easy it is to get something simple up and running in FHIR, and why it's a really nice model for modern programmers that are used to building applications based on HTTP requests for data. As far as the standard timeline and progress, as standards go, it's moving very quickly. Now, standards often move very slowly. So I'm not sure how much that's saying, but it's saying something. In just a matter of a couple of years, we've really gotten to a pretty mature second draft of the standard for trial use. So you'll hear people talk about the DSTU. That's a draft standard for trial use out of HL7 that is available now. They've released the second one in August, I believe, and there are implementations, multiple implementations of that you can test against right now to see if you're building applications that meet that standard. The normative standard would typically be the next step. Normative is the term that HL7 uses to talk about the final standard or a locked-in standard. And I think that the committee in this case is delaying that normative standard a little bit in order to make sure that they get really mature implementations of each of the components. And what they've done instead is to adopt a maturity model. So they're labeling each component of the standard with a number of 1 to 5 that make it easy to identify the stable components so that if you're using the trial version for implementing real work, you can tell which components are most likely to change or not change. So I think that's a nice model, and I think it's going to give them some more flexibility to finalize some of the more complex components of the standard that you may or may not be using at this point before they lock it in. So we'll see how that plays into their timing for the normative standard. I think another milestone that was worth noting, and John mentioned it earlier, is the Argonaut project, which is an industry consortium working to standardize interfaces for their use. And I think it really indicates the degree of industry support we're seeing behind this standard and the momentum for it. And then lastly, I think the really telling part is the number of EHRs, health application vendors, interoperability vendors, and especially hospitals that we're starting to see adopted and build real applications in it, or real infrastructure for mobile applications within a hospital, for example, or within a health institution. So there's great initial progress going on, and it really feels like it's snowballing. So what's my advice around this? Well, first, my advice is that I think the standard is usable today, that there are lots of components of the standard, depending on exactly what you're doing, that make sense to use as building applications for healthcare today. I wouldn't necessarily wait for my EHR vendor to open up a complete set of interfaces. I would consider bridging solutions. I think if your alternative is to build a proprietary interoperability interface, I think you would be better served by building to the FHIR interfaces and evolving that application as the standard evolves, if it does. So that's my main piece of advice. The thing I'd really like to leave you with, though, is Graham Greaves' metaphor of the walled garden of EHR interoperability, right? Where even in institutions where we've managed to do a great job of getting applications to talk to each other, we've done that by building interfaces between 1 or 2 applications or settling on a interface provided by one vendor. And within our garden, within our institution, we can get applications to talk together. But as soon as we have another application we need to bring in, or as soon as we need to communicate with another institution, we find out that we've been doing it inside a very narrow walled garden, and we don't have semantic interoperability. I think it's incumbent on all of us really to work toward breaking down the walls of that garden so that we can exchange data across the healthcare continuum so that we can provide interoperability throughout the care pathway. Thank you. And John, shall I pass it off to Ken?
Yeah, why don't you? I think, Ken, why don't you take it from here?
Oh, actually, I'm sorry, one more thing. I do have a slide in here for folks with some reference material in it, with some links to things that it would be great to look at. The HL7 standard, of course, some FHIR slides that I used in preparing this presentation, and pointer to the Argonaut project work.
Perfect. Thank you, John. Ken, you're on.
Terrific. Hello, everybody, and John, thank you for really a terrific summary of FHIR and getting us all up to date. It is clearly a train that has left the station, and there is a very specific use of FHIR that a project I direct called SMART has made, and that is to enable essentially an app store for health model based on an opinionated and well-defined, but also not overly ambitious API to healthcare data. So essentially, if I can get this next slide, here we go. Let me give you a motivation as to why we want an API that lets us run apps at the point of care. So an ACO wishes to buy a product. Let's call it Medtastic. It's developed an elegant meds manager. It encourages all the kinds of things that an ACO might want, like brand to generic switches, monitoring of adherence, reporting adverse events, and it needs to get some data from the health system. It needs some prescribing history, maybe some dispensed medication history. That dispensed medication history may come up through the EHR, through a SureScripts connection, or it may come to the side directly from SureScripts. It needs allergies, that's in the EMR. It needs problem list diagnoses, that's in the EMR. And so what happens to a company like this in general? Well, you know, there's hundreds of companies like this, or at the very least, getting all kinds of VC funding now. And their life cycle tends to be sort of disappointingly short if they require integration with the point of care, but need to essentially make a sale to each site of care as they go. And they end up with a nice innovation, maybe some nice software or software as a service, but it never really plugs into the point of care because each site of care will have a different electronic health record product, or perhaps even when there's an economy of scale and they're selling to a number of systems that have bought the same product, the integration will require customization locally because the data may not be represented the same way in the system, even between different versions of Epic, different installations of Epic, or different installations of Cerner or Meditech, for example. So there is a tremendous need to enable apps and new products and innovations to make their way to the point of care in a way that integrates with the health system data. Again, I'm going to contrast this to the tens of thousands of apps that are in the Apple App Store and Google Play that are in the healthcare category, but they really are not connected to health data. They're really something maybe patient-facing, but really quite separate from the healthcare system. I'm talking about apps that plug in at the point of care or that use data from the point of care and display it on a mobile device. So what happened was when the Meaningful Use program was first proposed in 2000 and at the end of 2008, just after the election, my colleague Zach Kohani and I wrote a piece in the New England Journal that said, let's look at the opportunity to reimagine electronic health records as iPhone-like platforms. And what we meant was a platform like the new iPhone. The iPhone was only a year old when we wrote this, that lets you add or delete an app. We said that that principle of being able to add or delete easily is something we called substitutability, and that substitutability was a very interesting and new way to express interoperability. And we didn't mean mobile specifically at the time, and we didn't mean the iPhone itself, although Apple thought we meant the iPhone, and we got to have some very nice conversations in Cupertino and an ongoing dialogue with headquarters there. But what we really meant was being able to run probably web apps, for example, that connect to the EHR that can be added to or deleted from the electronic health record. And what the basic trend was at the time was that there would be there were 10,000 apps on this iPhone when we wrote the piece, and at that time the iPhone was like, people were looking at this thing and kind of asking themselves, why does an iPod need to make phone calls? Exactly. Why does why does my music device need to make phone calls, or why does my phone need music on it? And what really happened was that Steve Jobs defined this tremendous opportunity, which is to allow third-party developers to create apps. So 3 months after we wrote it and it was published, the number of apps in the App Store had gone from 10,000 to 50,000, and this became a real, a very important hockey stick happening in the consumer IT world that inspired the approaches we began to take in health IT. So the way this looks is that if you have an electronic health record in this model, you've got apps that are created by third parties, and you can essentially, again, take an app, make your same EHR or two different brands of EHRs, get apps from some collection of apps, and create new functionality that's customized to the end user. We managed to parlay this into a grant from the Office of the National Coordinator. So along with the $48 billion that were allocated for electronic health record adoption and the Meaningful Use program and related programs, there were $60 million given for research into next generation electronic health records. And what we did was manage to successfully compete for one to define this application programming interface, an API for healthcare that would take us into an app store model for electronic health records. So the SMART project, which was funded under this program called SHARP, is really just a few things. It's standards and standard formats and protocols that redefine interoperability really as substitutability, a bunch of open source development tools and resources, and a public gallery to connect apps and users together. Now, what happened was that we started to eat our own dog food right away. We produced a candidate release API, and we gave a very nice app image, which was published in Wired magazine, and you can see it there on the left. It's like a little nice graphic of what a cardiac risk application could look like if you were to advance what a laboratory information system is into a more web-based paradigm. But it was published in Wired magazine just as an image, fully implemented in Photoshop by a quite inspired graphic artist named Dave McCandless. In 8 days, our software developer turned this image from Wired magazine into a functioning app that ran across 3 different electronic medical record systems immediately. So 4 months into our 4-year project, we demonstrated that you could add or delete this app across the API, that's substitutability, and also that the same app could actually run across multiple electronic medical records. That's reusability, which is the R in our acronym SMART. I'll give you an example of other approaches that an apps model enables. This is the immunization record pulled across a homegrown electronic medical record that John Glasser, who you heard from earlier, knows very well. His baby, the longitudinal medical record at Partners, we pulled the immunization record across a smart API into this app, and then we sent a file with the immunization record securely to a decision rules engine in the cloud. The rules engine fired the CDC rules, and the forecast of immunizations needed next was returned and displayed in the very same app here in this nice familiar-looking immunization table format. What this allows, and what is really one of the next frontiers in apps development, is the integration of third-party decision services that apps can develop, that apps can utilize, rather than having to program everything locally. One could imagine that there could be actually a single server managed by the CDC or anyone else that handled all immunization forecasting for an app such as this, where every time a rule changed, it would need to be changed in only exactly one location at a time. So decision support is one example of what we can get from this. We've got FHIR. What SMART did about a year and a half ago is we became very involved in not only the development of FHIR and participate in the core development process of FHIR, but also we swapped out some RDF models for FHIR models, which lets the SMART standard evolve rapidly and hand off essentially aspects of the health system that are well modeled and standardized to be managed by standards organization, HL7, as John Hotchkiss was describing before. So we've got essentially SMART constrains FHIR well beyond its natural state. In FHIR, there are profiles around each resource, which means that you can still express, for example, a sodium in a few different ways. And we constrain it with profiles using LOINC terminologies within for laboratories for something like a sodium, and we wrap this in an OAuth authorization network, OAuth 2, which allows us to have an app that actually runs in and authenticates itself to an EHR. We have gotten tremendous support from the sort of medical, industrial, government complex, and have an advisory committee with a series of companies and government agencies that are supporting SMART and working with us in implementing SMART within their own strategic plans within the companies. We had a meeting of this whole group last week, and I was stunned. I knew that about half of the companies were actually using SMART in their own organizations, but I was stunned to see that it's actually virtually 100% of the companies are using SMART in their organizations now, and there's just tremendous uptake. There's the SMART project also features this gallery, which is an open environment for showcasing your work. These apps will connect to SMART and Argonaut systems as they emerge. And also the opportunity is to show your apps working. The SMART Gallery actually has sample data, and you can demonstrate your app working to potential users. John mentioned the Argonaut project, which is one very exciting example of a translation of SMART. The Argonaut consortium or project is 5 electronic health record vendors as well as some health systems who have come together and are really implementing SMART in the final model. That's the FHIR resources, the profiles, and OAuth coming together in this Smart on FHIR implementation that lets us actually look forward to being able to run smart apps in live EHR settings in the context of the EHR in 2016. The White House has identified SMART as a key principle, as a key component of the Precision Medicine Initiative, and Meaningful Use 3, which focuses in part on an API for patient data access, is another very, I think, impactful outgrowth of the SMART project. Because SMART was not yet live with enough patients for the committees to ratify SMART specifically as a standard to use. MU3 was a little bit more general in specifying the API. That does create a little bit more risk to interoperability without something fully specified. So it really is up to the health system and vendors to come together to agree on a specific standard. If there's a VHS and a beta, that's fine. But if there's 10 different standards, it's going to break interoperability. I'm going to put up here a couple of URLs for folks who are interested in exploring further. Thank you.
Well, thank you, Ken, and also thank you, John, for some terrific stuff in a relatively short period of time. Obviously, we have some time for some questions, and some questions are coming in on the from the folks who are listening in. But why don't I start with one particular question, and both of you have mentioned this. To what degree are the major HIT, and particularly the major EHR vendors, embracing FHIR and SMART, and why? Why are they doing that?
Okay.
Either one of you.
So is that a question for me?
For both of you.
For both of
so
us.
however,
Yeah. Well,
yeah.
Let me jump in, and then John can comment as well. So I think what we see is I think Cerner has been the most vocal and the most advocating for SMART. I think Cerner definitely understands the value of an open standard that is pre-competitive and that enables this large marketplace for apps. But in the Argonaut project, we really see 5 vendors committed to implementing SMART in, and this Argonaut version of it, which is essentially a hardened version of SMART, going in, again, in the last mile into the products. So there is, I think, if we keep our eye on the ball, the opportunity to really try to work towards a true interoperability where the same API is implemented widely, and where the mantra for SMART is that an app written once should be able to run anywhere. An example of that, just briefly, is that, for example, after in the midst of an Ebola epidemic, I wrote a piece in JAMA, and it said, well, wouldn't it be wonderful if the CDC could help change triage criteria or help identify high-risk patients by exposing risk based on geographic origin to an algorithm that defines risk. Wouldn't it be great if the CDC could release apps that do those things in real time, in the midst of a crisis, and all people had to do was to update their triage criteria module the same way you update Angry Birds to the new version on your iPhone when you see that little number, that little red, white number in a red circle down in the corner of your app's store icon. John may have something to add there too.
Yeah, I think what Ken said is exactly right. I do think that the HIT vendors are motivated, largely by competitive issues. And for many years, interoperability hasn't been a very competitive issue. It's been a feature that's required, but not as critical in the sales situation. Now I think, especially as more interoperability, as more HIT vendors are getting whole house sales, it has become increasingly important for the customers that they provide good interoperability solutions. So I believe that those companies, the vendors, are seeing it as an opportunity to differentiate themselves, or worse, as an opportunity to be left behind if they don't adopt this. And that, I think, explains some of why we're seeing almost a unexpected level of support for standardization from the HIT vendors.
Fair enough. Question that came in, and I've heard this too. We often hear the phrase "smart on FHIR." So, I think, Ken, you brought the two of them together, but to what degree will we see smart without FHIR or FHIR without smart? Is the two really joined at the hip like that, or should be joined at the hip like that?
So, that's a great question. So, we began with these RDF models, and they were actually quite appealing to a segment of the developer community, but not as appealing to as wide a segment as we needed, because we really need developers to develop against the SMART standard, or it doesn't help, number one. Number two, we were looking to actually transition to JSON, and we identified this relatively fledgling project called FHIR that was really doing this in an interesting way, and it was just becoming sort of phagocytized into HL7 as, in a sense, almost like a wholly owned subsidiary run by a tremendous innovator and zealot, Graham Grieve, who makes this FHIR community go, and who started the project. So, by SMART's using FHIR, it enables us to hand off to a standards community that standards process, and at the same time, it enables us to use resources that are not yet defined by FHIR for innovative data types. So it may be a while before certain types of patient-generated or smartphone-generated observations end up in FHIR. And in the SMART world, we can implement that in our API, and we can create apps and essentially provide a testing ground for others. It's ideal when a standard is being developed and ratified if those standards have been used previously in the real world. So SMART really is the real world implementation. The project has always had apps that really use the API resources before we fully define our API. So this is the testing world. Right now we're doing a lot of testing in genomics, in decision support, things that are ahead of where FHIR is in many ways, but we see this as sort of a natural relationship where the rapid innovation and iteration happens in SMART. The standards eventually become ratified in FHIR, and then SMART, SMART updates to whatever the precise form of the standard that was ratified, and the innovation cycle continues.
Fair enough. John, anything to add?
No, other than to confirm that I've heard people in the FHIR community talking about adopting some of the pieces from SMART to make sure that they get integrated into the FHIR standard as part of the standards process. So I think the process is working as Ken describes.
Yeah. So we'll see SMART apps that are, quote, ahead of the FHIR standard. So you'll see SMART without formal FHIR, I guess, for lack of a better way to put it. And similarly, we'll see people who are using FHIR as the standard, but not necessarily SMART apps on either end of this. Okay.
Yes. Yeah, FHIR without SMART there's all kinds of things you can do with FHIR besides run apps. You might just want to grab that sodium and do something with it, or give it to someone else, and FHIR is good for that as well.
So a question here is, could you have a FHIR cardiac risk app interact with data from another app, such as an activity monitor, and then calculate a modified risk based on the other data? So toss it out to either one of you.
Yeah. Well, I'll just say that's a very good question. In fact, when we did go out to Cupertino right after our New England Journal paper, that's exactly the conversation we had with Apple. And it was a very theoretical conversation. And, Apple did not allow apps to talk to each other. And we were thinking, well, because in Apple's like, well, what could we do in health? And we said, well, the apps would need to talk to each other. And what we decided over lunch was that if there was a core of data, then that could be accessible to two different apps, like a medication list, then you could have inter-app communication essentially, but without the security risks of opening up apps to talk to each other. And so the answer to your question there, I think, is there's a few ways to do it. One is you could put the data back into the electronic health record and get it out in the other app. The other is you could have a third place where those data reside outside the apps layer and outside the electronic health record in some cloud-based resource. Or we may need to start to think about secure modes that locked down enough to maintain security, where certain apps are allowed to talk to each other and where we can get more interoperation that way.
Okay. John, stuff to add?
Yes, briefly. I think it's interesting to note we always we think about FHIR servers as being supported by the health IT, by the main EHR, but it's not necessarily the case. There could be interoperability vendors that support the server to serve data, and there could be other intermediary applications that you can talk to under appropriate authentication that serve FHIR data. They just have to obey those protocols. And in fact, for the FHIR standard is really nice at having a meta description of what protocols a server supports, so that you could have a fairly limited FHIR server that supported providing to authorized applications some data. It wouldn't have to go necessarily back to the EHR. So there's some different architectures you could imagine that would allow applications to communicate through some intermediary, if not one to the other.
Yeah, that refers to a question that was posed earlier, that is, can you describe the FHIR server and its location? And it sounds like the answer is there will be multiple FHIR servers offered by different purveyors, and whether they're Cerner, Epic, or Athena, or to your point, third-party integrators who will have FHIR-based servers who, help support the interchange of apps that are on either side of that.
Exactly.
Okay, terrific. The question here, and I'm not sure if you gentlemen can answer that's helpful, is when do we realistically expect versions of Epic and Cerner that support FHIR actually implemented by major customers? I suspect you could include Athena and other major vendors that are involved here. I think I don't know the answer for Athena or Epic or anyone else, so I think if that's who your major EHR vendor is, it's a conversation you need to have with them. And I also think it's not as if that sort of ability to support FHIR emerges full-blown, like the adult born, full-blown. It moves. So there's an initial set and then a subsequent set that moves as the standards move, et cetera, or as the vendor's comfortable with early releases to, Ken and John's point here. The Cerner has announced just a couple of weeks ago the first production level support of FHIR standards, early form of it, not a complete set of FHIR standards. So I think we're beginning to see production use being put out in generally available software. Again, you'll have to check with the organization that provides you your technology. And I know some customers are just beginning to use that capability at scale. So I think we're still fairly early. By what we say, by how implemented one thinks that is, and we're still fairly early in the major vendors offering as part of the sort of normal GA release of their products. So I don't know, John or Ken, if you have anything to add to that, and if so, terrific. If not, we'll go to another one.
Yeah, I think you said it well, John. There's early work, and John Hotchkiss referenced the ability to run FHIR servers that are EHR dependent, but at the same time may extend their capabilities.
Right.
Fair enough. Let's see. Can you describe an example of how a radiology practice would use SMART and FHIR? You want to?
John, are you interested, or should I jump in?
Yeah, I'll take a first stab at it, and then I'd be interested in your thoughts, Ken. Um, of course, it depends a little bit on what you're trying to do in the radiology practice. At this point, what FHIR and especially SMART is trying to enable is the ability to find or create third-party applications that let you build added value onto your core data stores. So if you have collections of information, let me think for radiology, what would be a good example? Say you're building already a workflow application to support your radiology practice, and the one provided by your EHR doesn't do all the things you need because you've got 4 different sites and 10 different facilities or whatever. And so you're building a little custom application. You'd like to have it be able to communicate, but you actually have perhaps 2 different radiology systems in those 4 sites. You could build a single app, build the FHIR interface to communicate, to let that app speak between those 2, to communicate to both of those underlying radiology systems. So that's, I think, is what we'll be seeing for a lot of the earlier adoption of FHIR, is building these proprietary or buying proprietary apps and using FHIR to let them interact with multiple systems or interact in a standard way with your system when they might have been built for a different system. Did that help? Maybe. Ken, what do you think of that?
Yeah, absolutely. There's the opportunity for customized workflows for radiologists. There's the opportunity to bring images in either through APIs to PAC systems, or if the EHR is already integrated with the PACs, to bring up an image through the EHR core. There's the opportunity to call decision support services, which under PAMA for radiology ordering are actually going to be required in the relatively near future. So I think there are some opportunities also to bring in CDS, clinical decision support, around radiology imaging, which is required for reimbursement, using service-oriented architectures that are facilitated by the availability of smart apps.
Okay. Thank you, Jim. One question that's maybe close to our last one. You described FHIR as being a good framework for building applications that interact with existing data. What do you recommend to people who are just starting to develop new data repositories, or, for example, new fields within the EMR or standalone databases and registries? What would you suggest to them given the emergence of these standards and approaches?
Oh, good. I was hoping we'd get to that question.
Well, it's all yours, John. Go get it, Tiger.
because I'm working on a project like that where I'm building some new interfaces, and it's really interesting to sit back and say, okay, instead of doing the data modeling from scratch here, I can take a look at the FHIR resource definitions and maybe even represent the data in FHIR compatible ways as I build this data out. If I'm using a database that supports JSON representations like Mongo, that means I can actually store it the way I'm going to want it when I pull it out for interchange. So it's a really interesting opportunity to take advantage of a lot of good thinking that the FHIR group has done about what components you ought to support in these different resources, and model the data store around that. It doesn't have anything particularly to do with the standard, except it makes it very easy to support it. And you can imagine a future where EHRs and data repositories are really, just the storage, and FHIR is used to get data out, even for the internal implementation of that EHR user interface. User interfaces would be interchangeable. So it's a nice futuristic sort of question. But practically, there's some very good thinking that they can take advantage of.
Ken, anything to add?
No, I think that's just right.
Okay. We're close to the final hour here, or our hour here. I'd like to thank Ken and John. Really nicely done. you gentlemen, both the presentations you had and the responses to the questions that you had. So anyway, thanks to both of you. I also want to thank all of you who took time to listen into this, and particularly those who took time to answer questions or ask questions. I wasn't able to get to all of them, but the ones that we got to were helpful and informative, et cetera. So before I turn it back over to Eric for closure, I just want to again thank you all, and hope you all have a spectacular Thanksgiving, and look forward to seeing you sometime either the remainder of this year or next year. So thanks a lot.
Thank you, John.
Thank you, John.
All right. Thank you so much for that very informative presentation. Shortly after we wrap up, an exit survey will be popping up on your screen, so I'd like to ask the audience to please take part in that. Thank you, everyone, for joining us today. You'll receive an email in the coming days with a link to the replay of the webinar for you to view again or share with a colleague. Thanks again, and have a wonderful day.